Okay, we're going to be measuring the percent grade of this ramp over here. Percent grade is measured by the height of the ramp over the length that it spans. And so this is going to lead us into a discussion of right triangles. So here we go. First what I'm going to do is, I'm just going to cut the ramp off here at this post and figure out the percent grade from here to the end. And so I need to measure the height. That's a pretty simple task. 12 3/4 inches. So we've got 12 3/4 inches of height. Now what I'm going to do now is just measure the distance that it covers along the ground as if I was walking along the base of the ramp. So here we go.
I'm going to go with Melissa next.
Okay. Alright, from the post to the end, 152. So the percent grade is going to be given by that 12 3/4 over the 152. This is what they would do with streets or ramps to try to get them up to like Americans with Disabilities Act specifications and things like that. Alright, so that's going to lead us into our discussion of right triangles today. In the intro, we talked about percent grade. Percent grade is a measurement of how much something goes up over how long it is, okay? And so when we talk about percent grade, in San Francisco there's a lot of hills, okay? I've never been there, but just watching TV and kind of seeing it, knowing about the city, there's a lot of hills. And so the steepness of a road could be classified by percent grade. Well, percent grade and angle of elevation are really actually very related. And so if we have Filbert Street, in San Francisco, it has a 31.5% grade. This means that it rises 31.5 feet over the length 100 feet. This can be given as an angle. The angle can be given by the amount that it rises over the amount that it goes. And this actually coordinates to a 17.5 degree angle. And we're going to see how exactly we do that using trig ratios. In example 1, we have something like this. Use the trigonometric ratio of cosine A equals 0.6 to determine which angle of the triangle is angle A. Well, if I say that cosine A is equal to the adjacent leg over hypotenuse, that means that the cosine is the adjacent over the hypotenuse, remembering, of course, SOHCAHTOA, adjacent over hypotenuse, is given by that. Well, for angle 1, the cosine of angle 1 equals, and I'm going to say adjacent, so that's 3.6, over the hypotenuse, which is 6. The cosine of angle 2 is equal to 4.8 over 6. Calculator time. Which one gives me 0.6? Well, when I calculate this, I have 3.6 divided by 6 gives me 0.6, and the other one gives me 4.8 divided by 6 equals 0.8. So obviously I can see that the cosine of A, if it's equal to 0.6, then angle 1 must be A. I can label it A. Do you see how that worked? If I'm given an angle, I can find the cosine, and that's okay. Because if I can find the cosine, we're going to see in just a minute how we can use that to find a side length. Okay? Now, here's one for you to do. I've given you two things. The sine of A, which we don't know what A is, and the tangent of A, which we don't know what A is. Figure it out based on SOHCAHTOA. And that will help you determine which angle is angle A for A and B. They may be different ones. So try that one. We'll talk about it in class. Let's consider the sine of 30 for a minute. The sine of 30, as we recall, if I draw out this triangle, and this is my 30-degree angle, I know that this is x, this is 2x, and this is square root of 3 times x, given the fact that this is a 90-degree right triangle. The sine of 30 is equal to opposite over hypotenuse, x over 2x, which it equals, after I cross out, 1 over 2. So the sine of 30 is equal to 1/2. That is always true. So what I'm saying is, if we know the sine, the cosine, or the tangent, meaning we have a decimal value for it, we can use inverse ratios. Here's how that works. If sine of A equals x, it follows that sine inverse of x equals A. Sine minus 1 means sine inverse. It's on your calculator. It's the second function. So you hit the yellow button second, and you hit sine, and it'll come up with a sine minus 1. In the same way, if cosine of A equals x, it follows that cosine inverse of x equals A. If, tangent A equals x, it follows that tangent inverse of x equals A. Your calculator has a list of values. If you put in an angle and take the sine of it, it spits out a decimal. Well, if you put the decimal in, it can also work backwards. So that's what we're going to be doing here. In example 2, calculating angle measures from trigonometric ratios. If I take this and punch this into my calculator, I hit second cosine 0.5, enter. It gives me second cosine 0.5, enter. 60 degrees. That makes sense. I'm going to do the same thing for sine inverse. Second sine 0.45 equals 26 nearest degree. This is 26.74 degrees, so that means it's going to go to 27 degrees. In the same way, I'll do tangent inverse. 3.2, 72.64 degrees, which means it goes to 73 degrees thereabouts. Use your calculator to do these inverse ratios. It has a chart in here that you can use. Use it. Because when you do sine inverse, it's saying, I have this decimal value, please give me the angle. In the same way you could say, take the sine of this angle, please give me the decimal. It works backwards. Try this one. The next step to this is to apply it overall to the triangle to find the angles and the sides. We're going to do that next time. Thank you for watching. We'll see you next time.